Good afternoon, everyone. If you are here for a local host live, you're in the right place. If you're not here for that, stay anyways. Um, it is 4 o'clock, and I'll call this the seventh inning stretch. If everyone where you are could just stand up where you are, if you're able to and willing to, we're not going to do anything like fancy. Cool. So first thing I just want you to do is just arms to your side if you have space, straight, make a T. Arms go up, look at your fingers, and then back down to your side. And then with me, we're going to take our shoulders. We're going to inhale. We're going to bring them up to our ears like this. Inhale. We're going to squeeze. A squeeze, squeeze. And then exhale. One more of those. In and out. Putting us back down. That was mainly for me, but I just made it a group exercise thing. Um, okay. My name is Trey Clark. I'm currently a software developer at the University of North Texas. And today we're going to talk about how to take your app to localhost live. So I'm going to give you a scenario. Imagine that you just built the app. Um, you could fill in the blanks of what that app is. Um, the only issue now is you have to get that from your computer and ideally distribute it globally, right? So how do we do that? There are many different ways to do it, but the easiest thing that we can use at this current moment is the cloud. Now, this talk is going to go over a lot of cloud concepts specifically geared towards Amazon Web Services. Now, a lot of these cloud sort of ideas can be sort of like cross use between a lot of cloud providers, but this one's specifically geared towards AWS. So, how do we get from our local host, from our local machine to the cloud? First, why the cloud? So, um, it offers us scalability. It offers easy collaboration from person to person. It's also a lot cheaper, right? We utilize a pay-as-you-go model. We don't have to think about purchasing overhead or any sort of additional server racks for our own on-premises data store, but we can utilize someone who's already bought it for us. Now, with this, we want to think about something called the Well Architect Framework. And what this is this idea of as we have these conversations about building out cloud architecture, how do we actually implement to see the most success, right? So our six, we call these pillars of the Well Architect framework are going to be our operational excellence, security, performance, reliability, sustainability, and cost optimization. We're briefly going to go over these different pillars in depth, and then we're going to talk about how we can use these pillars to drive communication either within ourselves or with a team to find the correct microservices to deploy an app from, again, our local machine to distribute it globally. So, our first pillar, again, is going to be operational excellence. What this is really geared towards is automation, right? Automation is pretty much what we as developers try to strive for because that takes away sort of like the human error and also allows for automatic, reliable deployments, right? Proactive problem detection and continuous improvement, right? We have consistent, reliable, repeatable, low risk deployments. It also helps us with monitoring, right? So we're able to detect faults and find those issues quickly. And then also our processes for deployment, whether that be manually or with like some sort of playbook, is that in place? And are we able to handle any sort of incidents with that? And are we able to recover from those incidents gracefully? Our second pillar is going to be security. So, what we see up here is called the shared responsibility model. So, what this does is basically tells you, the consumer, what are you responsible for security wise within a cloud environment? And then what is the cloud provider responsible for? It could all be boiled down to you are responsible for things within the cloud, while the provider is responsible for things outside of the cloud. So some things in the cloud is just you are in charge of the code itself. You are in charge of the platform that you're using, the operating system, making sure that that's patched the way it needs to be, firewall configuration, and even encryption. Things of the cloud, so the things that your AWS is going to be in charge of, is the software that's going to be used to help you actually run your things, right? Um, so how is the storage being implemented? How is the network traffic being implemented? And then the hardware itself. I personally don't have the money to put hardware racks in different remote corners of the world. AWS does, but that's their responsibility to make sure it's both secured from like virtual attackers as well as physically. One of the key components of like security is like we like to think about like, oh, we have these firewall, we have these like IP blockers in place. That's fantastic. What about a lock and key or a wall, right? So those are some things that AWS takes care of that we don't have to. Our third pillar is going to be performance. So we're thinking about how our architecture works as a whole. So finding and using multiple solutions for this optimal workload. We have how we're holding and managing data, right? So purpose-built data stores that quickly retrieve secure data. We're thinking about how we're delivering that data over our network, and then how are we going to implement that sort of principle and practice throughout multiple different workloads, multiple different cloud environments, so they're all able to interact with each other. Yeah. Our next pillar is going to be reliability. So with reliability, we're thinking about sort of our first foundations of making sure our app is up for, ideally, we want 100% of the time. That's not feasible. So we shoot for 99.9999 repeating percent of the time. So we need to plan and execute quota management, which basically says my app needs this amount of resources and it cannot go more than this, right? Because once that happens, then we see some faults that happen in our app, maybe some shutdowns, maybe it doesn't restart so gracefully, things along that line. Workload infrastructure, basically how am I implementing reusable interfaces or microservices across all of my available services that I need to distribute globally. And then how do I change management? That being, how do I accommodate workload changes? Maybe one day I have 10 users, the next day I have 100 users, the next day I have 10,000 users. How am I able to scale properly without having any sort of faults within my application? And then how do I plan for those environment failures, isolate those faults, and then recover and learn from those in the future? Our next pillar is going to be cost optimization, which is exactly what it sounds like. Am I able to use the amount of services that I need with no more or no less resources, right? Most cloud providers offer a pay-as-you-go type infrastructure, and so you only pay for what you need. That's the insurance quote. Then we have usage awareness, which is basically, am I developing policies to define how these resources are going to be managed over time? Ideally, we wouldn't want essentially 6 virtual machines if we're only handling 10 people. On the flip side, we don't want one virtual machine serving our app if we're trying to handle millions and millions of requests a day, right? So being aware of how our application is being used, what resources it's using, and then making sure we find a balance between optimizing our costs as well as implementing these sort of pillars within our application. And then our last one is going to be sustainability, which is development that meets the needs of the present without compromising the ability of the future generations to meet their own needs. And this is similar to the shared responsibility model. The consumer or the user, which is us, we are responsible for sustainability within the cloud. So making sure that our data is working efficiently, making sure our code works efficiently, right? It's not drawing too much power. While on the other hand, AWS is in charge of the sustainability of the cloud. And so we're thinking about how are they cooling these machines? What kind of materials are they being used to build out these sort of like server farms, these data lakes, and with minimal waste, and maybe even using non-renewable energy such as solar, wind, et cetera, et cetera. So with those 6 ideas in mind, we can then start having a conversation of how are we going to build out architecture to deploy our app. So it's time to deploy. There are 6 steps that I like to think of when trying to go from ground one all the way up to full deployment in terms of getting something off the ground. So our first step is going to be, we have to define our requirements. There's 3 questions to this. 1, what kind of app? Is this going to be a mobile app, a progressive web apps, a web app itself, a web server? Because that really depends on, or really drives the question of what's going to be underlying that, right? The second was, what kind of storage do I need? Do I need in-memory data? Do I need something that can be pulled from other places? Is this going to be accessed like frequently, infrequently? And then lastly, what can I predict my traffic is going to be like? Again, am I going to need 10,000 requests a day? Am I going to meet the demand of 1 million requests a day? These are the questions that should be driving your architectural discussions as you're building out your virtual private cloud environment. Step 2 would be plan the architecture. There are 3 subcategories, which I think this is like the most in-depth that we'll get today on as we plan. So the first one is compute. What is actually going to power this app that I worked so hard to build, or your team has worked so hard to build? Second, again, how will the data be stored? How will it be transferred? And how are we going to protect that data? And then third one is the network. So how do people access my app? Who do I let access my app? Are there any protected views? And then how do I transmit data efficiently? And so we're briefly going to go through each of these 3 points, talk about what they mean, and then I'll offer some services that AWS. Well, I'll give you some ideas of services that AWS offers to meet these needs. So the first one is we have the compute. Compute, again, how are we going to run this application? So our first one here on the left, we have our EC2 or Elastic Compute Cloud. What this is just a virtual machine that basically handles all levels of different workloads. It's highly configurable, such as like operating system, what kind of hardware we're actually using, number of CPUs that we need, whether or not we want to use a graphics card or not, which can get a little bit daunting. There's a lot of configurations. So AWS also offers us optimized EC2 instances that we can use sort of out of the box. In most case scenarios, we'll just use the general purpose one, which is just for general purpose use, of course, such as like web apps, really things that aren't compute intensive. And then we can use an actual compute optimized one, which handles things such as gaming services or gaming servers, scientific calculations, or even media transcoding. And then there are other ones such as memory, which processes things like large data sets within memory. We have accelerated ones, which really handle more scientific calculations, large floating point numbers, et cetera, et cetera. So there's a use case and different type of instance for whatever you need for your particular application. Our next service here is we have Elastic Beanstalk. What this is going to do, it's going to help us deploy and auto scale our app. Whenever you see the word elastic, that means it refers to some sort of scaling, right? Whether that be provisioning resources, in terms of like RAM or storage, or even replicating data storages. That's what that term means, elastic. So it handles deployments by including resource provision, auto scaling, like I said, and also is health monitoring. What Elastic Beanstalk does well at is it is a space to deploy your backend services that are written in Java, .NET, Python, PHP, Ruby, Go, and even like some containers like Docker and Kubernetes. You can also optionally, because this is made for like a drag and drop, you can also configure these services as well if that's something that you wish to do. And then lastly, this is sort of like the serverless side of these compute services. Now, when I say serverless, I don't mean that there's no server present at all. We're just using someone else's server and resources. And so our first one here, we have Lambda. You might have heard of Lambda functions. What Lambda is, it allows you to create functions that only trigger when called, that live in the cloud. For example, let's say I have a social media app. Someone uploads a lot of pictures, but the aspect ratios are completely different. Well, what my service needs to do is it needs to take all of those photos and resize those so they fit how they need to be on the front end. Now, I could use my own resources, my own server for that, but that could be really compute intensive. So I use my Lambda function. I use the cloud services, the cloud servers, to run that for me. And then I just get that data back. Then we have AWS Fargate. This one's a little bit more straightforward. This one, it's a compute engine for containers. So if we're using the Elastic Container Service, Kubernetes or Docker, we can just throw that on Fargate and then it will deploy it for us since all the resources are there. It's very similar to if you've ever used like Heroku or Netlify or Vercel, where we just can kind of upload statically from there and we have all of our resources. So in terms of compute, there are a lot of services, but these are the main 3 services that I like to think about when I'm trying to come up with, again, architectural designs for serving. Our next one we have is storage. The most popular one that we probably know of is a simple storage service, which is S3, or you might have heard S3 buckets. This is an elastic, there's that keyword again, elastic object stored with many configurations, different retrieval points, retrieval time, and access points. There are 3 different types of S3 buckets. Well, 3 large sort of like overhead types of S3 buckets. We have general purpose ones, which gives about 1 millisecond retrieval time. and it's for frequent access, right? So if I'm doing something like, again, going back to that social media idea, if I'm pulling posts, if I'm pulling threads or conversations, things that like require multiple hits like a second, that's when I would use just the general purpose one. Now, because that one's in use as much, it's going to cost the most, right? So we're going back to that cost optimization pillar. It's going to cost us the most. Now, a little bit less of cost, we actually have it's called the standard infrequent access, or the S3 standard IA bucket, which is infrequent access. We typically think about a little bit between a month and 3 months of access. So a little bit more archival process. This is going to be less costs, but it also still stouts its 1 millisecond retrieval time. And then lastly, we have the glacial. Um, Glacial is really towards archival for long periods of time. So if I'm trying to migrate a data center or something like that, maybe I would store it for long term inside of a glacial bucket. You can retrieve it in variable times. It could be 1 millisecond, couple minutes, or even all the way up to 48 hours. However, this is designed to be taken out of at least once a year, but not any more frequent than that. This is going to be our lowest cost option out of those three sort of like S3 bucket tiers. Then from there, another solution, we can use the Elastic Block Store. What a block is basically a virtual hard drive. Elastic means that virtual hard drive can provision resources based on the needs that we need within our particular app, as well as we're able to share those resources, share that data between multiple apps. This is raw, unformatted data, so it's up to the developer to make sure that they know how to access and encrypt this data as well. And then lastly, we have the storage gateway. This is a hybrid solution, so it deals with the cloud as well as on-premises hardware to help you with your storage needs. There are three different types of gates. The first one being the file gate, which basically stores all of your objects in S3 and makes async updates whenever local files are changed. So if you think of like OneDrive, for example, you change something on your computer and it updates in OneDrive, vice versa, right? Our next gateway is going to be the volume gateway. This one, the volume block gateway. This one is basically like hard drive based as well. So the data lives either in the cloud or locally. And then where it's not, the other place takes a snapshot so we can view that data in real time. And then lastly, not as widely used, but still used in some places, we have the tape gateway. And what this does is it takes large data sets and just puts them in some sort of storage unit in the cloud. Back before the cloud existed, backups typically were on physical tapes like floppy disks or CDs, right? Those would then get shipped, put in a box, and shipped to some mountain facilities, some far away, in case something happened or something were to happen locally. And so that's what this tape storage gateway would do. And then lastly, in terms of our architectural design, we can think about the network. So your virtual private cloud is basically everything within your cloud environment that you're going to be connected and working with, right? So you can think about how you're going to configure IP subnets. You can think about your routing tables, gateways, peer connections, and even how you're going to monitor traffic to and from your app. From there, we can talk about security groups. This is actually going to control the traffic that is actually allowed to reach and leave your resources that it is associated with, right? Because again, we don't want to open up to everyone, especially at the start, but like small IP subnets, and then maybe open up from there. And then lastly, we have our Elastic Load Balancer, which is exactly how it sounds. It's a load balancer that is elastic, right? So we're taking in traffic and we're allocating that to specific servers based on the needs and resources that we have allocated to us. So now that we've talked about some of the services that build out our architecture, let's talk about the infrastructure itself. So there's a lot of text here. I'm not going to go over all the text again because it's a lot. But one of the key terms that we think about when we think of infrastructure is infrastructure as code, or IAC. What this does is IAC refers really to the automation part of deployment. So it's the ability for us to provision and support your computing infrastructure using code instead of manual processes. Automation is really the key goal when we're thinking about computing across multiple environments. IAC is used for infrastructure automation, of course, to create environments built to build, test, and also deploy. We have two services that are built in native to AWS to help us with that. We have CloudFormation and the Cloud Development Kit, which also implements CloudFormation inside of it. It helps us really develop those CI/CD pipelines. And then we have user management, which helps us securely manage and access your applications and resources. We want to think about least privilege here when we're thinking about these security groups. For example, I, as a software developer at the University of North Texas, don't necessarily have access to everything that the university has. And that's okay. Because if I did and I was irresponsible and someone hacked my account, they would also have access to all of that information, right? So I'm thinking about, as I'm building out my infrastructure, who has access to what and the least amount of intrusion as possible. And then as we're going through this, we're thinking about, do we have multiple environments, right? One for beta, one for testing, and one for actual production. So isolating these deployments using things such as code pipeline, code build, or code deploy, all AWS features, so that we can test these apps before we roll it out to production. So that's step 3, our infrastructure. Step 4, we have deployment, the actual deployment itself. So there are several different types of deployments. 3 I want to talk about really quick are just in place, which is updating existing code. And so that's like if I did a git clone and pushed something like that, or if I just went into the server and changed some code. That is in place. Then we have the blue-green, which is swapping traffic between multiple environments, right? So I have an instance over here that's currently running a version, and then I have an instance over here that's currently running a version. I'm going to update this instance over here and then switch the traffic over there while this one's still in the older version. And then lastly, we have Canary, which is just releasing a small amount of users to this new version over time. So going to the same idea, 2 different environments, 2 different versions, but slowly releasing people to the newer version until we get testing underway and we make sure that whatever's in production is actually stable. And so some services we can use, we've already talked about Elastic Beanstalk to help simplify app hosting and scaling with minimal setup or with highly configurable components. We think about Code Deploy, which helps us automate deployments to EC2, create Lambda functions, or even different Elastic containers within AWS. And then we can also have a combination of S3 and CloudFront for static website hosting as well. And then we also can wrap all of that up with CloudWatch, which helps us monitor deployments, performance, and set sort of alerts for cost optimization, any sort of malicious traffic that might come through, et cetera, et cetera. Step 5 is monitor and improve. So we're thinking about, once everything is deployed, once we have our architecture in place, how am I going to monitor the system? And so I can have visibility as a developer to make sure everything is working as needed to be, right? So again, AWS offers CloudWatch, which gives us metrics. This can be sent as a notification to you after the fact something's happening, or it can be used in real time. So you could detect malicious attacks or something of the sort while it's happening. Then AWS offers tracing with AWS X-Ray, which is basically we're tracing requests to our microservices because there are many different parts of our architecture, and being able to see those or see what's happening within those microservices is super imperative that our entire infrastructure works as needed be. And lastly, when you think about auditing, we have logs with the AWS API Gateway, which is the users themselves making requests or doing things within the gateway itself. So that's making sure the users, not necessarily the people from the internet, but like team members, are doing the things that they need to do to make sure that, 1, the compliance is being covered, 2, that the app is running the way it needs to be without any sort of malicious attacks, and 3, making sure that they are meeting those security and compliance objectives. And then our last step after we implement a security layer is we have to optimize post-deployment. So I'm cleaning up any unused resources. I'm setting up budgets and alerts. I'm using the AWS Budgets and Costs Explorer to catch surprises early. If workloads are stable, then we're thinking about savings plans or any sort of reserve instances for long-term money savings. And then post deployment, we know is also about sustainability, right size resources, and use serverless where possible. So once that's all said and done, you might have an infrastructure that looks like this, right? But we use, again, microservices because I could take any one of these pieces, take them out of the equation, minus the apps themselves, and the entire infrastructure wouldn't fall off. Cool. So with that in mind, hopefully this session gave you a little bit more ammo as you have these conversations to again start thinking about taking your applications to the cloud and building out an effective architecture. Again, my name is Trey Clark. If you'd like to connect, here's my LinkedIn. Thank you all for coming to my talk.